It should be back on. Let me know if you can hear me. Okay, nice. Benchmark. Move this. Demo string create. Okay. Let's see what happens. So we have a string like this. We create it with a string create method where we pass an action that modifies a span, basically takes a string and a span, and based on the string we can create this span, modify the span to create a string, something like that. Let's see what happens and let's benchmark. First, if it works. Oh, no, I don't want to benchmark. Comment. So the method works. So we implemented like we understood. Now let's go back to benchmarks. It printed C, so all is good. Now if we say that we do this with span create, what happens? And we don't care about those. Let's run. I commented out the benchmark itself. Let's comment out this one. Okay, run. Cool. Let's wait for the results. Tuples, I demonstrated tuples. Pre-processing, just the same stuff that is in the slides, nothing interesting. Reflection. Here I demonstrated basically how do you call a method, how do you call a different thing. So how do you call a method? Get method by name, by flags. So non-public static method by name foo, we get that method and then we can call it. I don't need this dummy probably because it is a static method. And very similar for non-static methods and very similar for methods that need an argument. Nothing special there. Creation, again I showed linQ, lambda, nothing very interesting. Yeah, so boring stuff here. Expression trees, unsafe code. Pointer demo is also something that we went through. Okay, for pointer demo. For pointer demo, the interesting bit is that we wanted to try what happens if we don't use this instead. Let's just move this to, let's say, what's this? Okay. Let's say this is V1. And let's paste this code. Pointer to array. Okay. And remove this. Oh, right. Like this. You see what you meant? Yeah. And then supposedly I can, yeah, I cannot do that. It's immutable. It's fixed. I cannot, not like that. You mean like that, just like that? The same thing except that like this. Anyways, back to benchmarks. It's wow, it's slower than our unsafe code, but it's faster than way faster than the string create. That's cool. Almost like our unsafe code. That's cool. Thanks, Donut X, for showing it. Always nice to know things like that. Oh, but it allocates. And it allocates even more. True. It allocates twice. Once for the string and once for the span. Show function. Okay. The function was... what was it? Benchmark. The function was this. So we do string create that is this big, this long for this text, and this is an action that sets character. I can rename it, I guess. That sets temp char to C. For example. Yeah, so this is almost as fast as ours, which is pretty cool. Anyways, console write line int pointer p+4, for example. Okay. p+4. So what happens? I don't make it, like, I don't modify p itself. I just do pointer arithmetics. So this should print forte. Will it print forte? I don't need to cast, apparently. So basically this. Okay, let's see. Let's run demo pointer to array. Unsafe code here. This is boring stuff. The other one is more interesting. Okay. It should print 50. Yes. So we are here. Wait, where's... Oh, sorry, I'm at the wrong place. This one. This one the reference, and this one the new one. Enjoy your meal, Aurora. Come on. Fucking hate that shit. What did I change? What the hell? I don't know. Okay. Go, go, go. Let's see. 12 was the last one from the other one. I'll explain why. And this one should print 50, you say. Yikes. Okay, printed 50. Yay. So this is equivalent to pointing at the start. Yeah. Point at the array. Probably, yes. Yeah. It's not a stupid question. I also have a bad understanding of pointers simply because I haven't done anything with them since first year of university. Okay. Benchmark. String create. What am I doing? Replace at 10. Copy the system create. Copy the span. Right. Okay, what the hell is going on? State as span, copy to span. But I need to modify it as well. State as span, copy to span. Okay. Span. Crap. I won't be able to name the method. Okay. Span 10 is C. Okay. I don't write, I don't know, it's just weird. It's just weird looking to me. This is bizarre. But okay. copy the span. Benchmark. Not debug mode. Okay. Makes sense. So we don't care about this. The elimination round, we don't care about this. We only care about unsafe and copy to span. In the meanwhile, let's cover the last thing that I wanted to explain. Well, back to unsafe code pointers. One interesting thing. So here we have a reference to the first element of array, which we store to the pointer. And by incrementing that, we basically point to a different array element in that array. And when we finally go when we finally, like, if we point to the reference, like if we increment the reference itself, it will actually increment the element, the first element, for example. So the first element was 10. So incrementing the reference itself will increment that element because it has 4 bytes allocated to it. So we can safely increment the pointer to that element. And it prints 11. If we increment it again, it prints 12, as opposed to incrementing the pointer to the array. So that's the difference. And we can do this and that. It's done. It's done. Okay. The results. Okay. Now this is faster. And quite a lot faster. And not that many allocations. Less allocations than the first one as well. Interesting. Thanks for sharing. Almost 2 times faster. Okay. Last thing that I wanted to show, expression tree demos. So the full demo is when we have 2 very similar expressions, basically lesson.name equals to lesson 13, and another one, lesson.name equals to lesson 1. So each piece of code like this, and this have its own expressions. So this one expression is here. This one expression is here. And this one expression is here. And this one expression is here. And when you combine everything, you have this. the copy to span is way faster, almost twice as fast. So basically we have two expressions that are very similar, and we can combine them with or else, for example. So we combine them, we compile them, we create lessons for input, and we can filter them. And the result will be that two lessons are found. And last one that I wanted to show, imagine we have a simple code for calculating factorial here. So what do we have? We take n for input, like for what number the factorial is, and while n is more than 1, we just multiply, keep multiplying result from n, and that is factorial, basically 5 times 4 times 3 times 2 times, that's it, n times something times 5 times 4. Basically, all the way from n all the way to 1, you multiply all numbers. And that's factorial. So factorial of 5, if you multiply everything, you get 120. You can do the same with expression trees, and it's horrible code, horribly ugly. So you have your parameter expression, and you need two expressions, one for the input, another for result. Then you have local variable. Sorry, then you have a label where you need to jump for return. And then you have a body for the method where you create a local variable, result. So you assign the expression, the initial value of result is 1, and then you start a loop. Basically, your loop end condition is when it's not greater than 1. When it's less than 1, you break the loop by jumping to the label that you put. And what do you do inside the loop? You multiply the expression, you multiply the result, which was 1, and you decrement the value, the parameter that you passed. And when you're done, you just jump back to the label, return the result. So what do? You have this expression, this whole full nice expression that you compile into a delegate, and you run the expression and you get the result, and it also prints 120. So pointers are confusing, unsafe code is confusing, and you definitely don't need to punish yourself for not understanding it at the moment, because in C#, in a vast majority of cases, we simply don't care, because it's all done for us and we don't need to care about low-level stuff. And if we do, then probably we would move on and use a different language that is suitable, that is specified for it, which is C++ or C. I'm not sure how does C or C++ compare in terms of speed. I think with unsafe code, we can have a similar speed. void pointer, pointer to anything. A lot of stuff that is yet to learn if you want to go deep inside unsafe code. And that stuff is hard because you need to understand well what you're doing. And if you don't, you can be in a big trouble. Pointer arithmetic, yeah. So before we close, I'll link the code. Lesson material. Push. Okay. Here it is. The code examples and the slides. Okay. Do you have any more questions? I'm not sure if I can answer, but there are people who can help me. So if you have any questions, shoot right away. In the meanwhile, I'll demo the expression trees last bit. Benchmarks, copying to span directly was better, and by quite a lot. And it won by 12 milliseconds, which is a lot. And expression tree is now the demo run. Show what happens. Nothing happened. Amazing, because I didn't uncomment the other line. Factorial. Why isn't it printing 120? Should have printed 120. Huh? I did? Expression trees demo, run, demo link queue. What the hell? Okay. This one is a fail, that's why. Yep. Sorry. Okay. Makes sense. Okay, so here is a proof that both do the same. Simple factorial, simple nested local function 120. And also the same with an expression-based function. A lot of complexity, but a lot of flexibility as well. In any case, a super rare condition when you should care about this. In most cases, of course, second one suffices. Oh, span. Indeed. All right. Um, I think this is all I wanted to show. A lot about everything, and I presume that it wasn't very clear the way it was explained. But my point wasn't that. My point was to just familiarize you with a bunch of different concepts that aren't that very useful in daily programming, but that can save your ass when you get really stuck into problems for performance, um, for just having a need to call something that you don't have access to, and similar, or like creating dynamic stuff out of expressions. I think the only useful thing that you could apply daily is tuples and deconstruction of tuples. So yeah, welcome back, Aurora. Unsafe tuples. Don't go that road. Don't go that road. Um, a few things now to mention. Uh, Let me check my phone. Maybe the guy replied. So I got in touch with one person who does the project. Well, I always had him in touch. He just has a big delays, really big delays of replying. It's the native North American Indians AIDS Prevention Center non-profit board member that could ask our help, and I'm still in progress of just having a good conversation with him. Maybe he's a troll, I don't know, but it's something that we have and that we should at least try. If it fails, if it doesn't succeed, I'll try to look for something else and I'll give it half a month more. And if we fail, then, we'll do our own project. I also lean to like 60-70% that it's a troll. But yes, I'll try a few things before we can decide on our project, before we settle on something. Uh, Workplace didn't work out. They said they don't need anything. My chief head of communication tried to contact a nonprofit, local nonprofit, but they said they don't need anything. The food bank stuff. So now I'm just looking at nonprofit Reddit for something. Quite hard. I think he was trolling. Unsafe tuples don't exist as far as I know. Why would it be unsafe? Oh god. Tuple expression. or better, expressions in tuples. Or tuples which hold expressions which hold tuples with expressions. Crazy. Lambda tuple. All right, guys. That's it for this lesson. Sorry if it was a lot for to crunch. I understand. Don't hit yourself if you couldn't understand much of it. But that wasn't the point again. The point was to introduce basically the last missing pieces of C sharp that are quite important for higher levels of programming, for if you want to reach for seniority. Those are the topics that you should be aware of. And yep, that's it for this lesson. Next lesson will be in 2 weeks or in 1 week time, because I'm taking a little break before we start another chapter. And I'm very excited for the next chapter. It will be test driven development. We'll talk about XUnit, how to write tests, about auto fixture, about fluent assertions, about test patterns, about integration and unit tests, and about how do you write test before you have code for it. So it'll be a lot of things, and I'm very excited to give that lesson because unlike this topic or deep C sharp features, that topic is my strong point, and I really, really want to teach what I know. Unsafe unit testing. No. Dispose yourself. Thank you guys for watching, and see you in a few weeks' time. Bye bye.